Okay, and so the next one is by Joseph. Well, I don't think Joseph needs much introduction, and he already was a speaker yesterday. So let's just jump in the Unicode land, I think.
Yeah, so if you just look at, I think Paolo's got at least some. Okay, that better? Yeah, so it struck me, I think, that Paolo's probably got some contribution to every talk this session. So Paolo drew this picture, so he gets his contribution in here. So that's meant to be me, I think, in Unicode land. So this is the third time I've used this slide, actually, for introduction. So I've been to 3 TUG conferences, and I've had this slide as I think at each of them with something about Unicode. So we're continuing to explore Unicode land, as it were. Okay, so I started actually last time I was talking this area with this quote, but I thought it still makes a good introduction from Don Knuth about how important Unicode is in order to sort of bring order to the case, or at least some order. And people have commented in coffee breaks and things about the fact that some of Unicode is less than perfectly ordered, but it is at least agreed on, and people in the main do try to stick to it, which is actually as much as anything important. So previously, yes, I've been exploring Unicode land for a few years now. So some time ago, before we integrated Explore 3 into the kernel, I decided to come up with a way of doing case changing this now feels like an age ago, when the vision was that there would be a new LaTeX 3 format, and when, at least in my mind, that would mean we would only have to worry about engine native input. And so I wrote this code that would expandably case change text in Unicode engines using Unicode data. And the idea was that I would leave pdfTeX just to ASCII input, and then that wasn't quite good enough, and so then I'm going to put partial support for 8-bit engines. So I did some work. We sort of decided we would need that case changing code eventually in LaTeX for other reasons to do with handling active characters, particularly in 8-bit engines. And so I wrote so we changed the plan a bit. So I wrote some support for 8-bit engines, which was like, the idea was then, okay, well, you only need to cover the code points in 8-bit engines that you can typeset. So those that are reasonable in T1, in LGR, et cetera, et cetera, et cetera. That means you end up with 2 code paths. It's a bit awkward. There's all these edge cases that you keep forgetting about. But it was still okay. And then this is going to stop working. There we are. So as those of you who haven't seen previous talks on this, so the idea was not just to do a one-to-one mapping, which is the sort of classic Knuth model, but to do what Unicode have established is necessary. So context-sensitive mappings, particularly the fact that in Greek, sigma at the end of a word looks different. When you lowercase it, it looks different from a sigma in the middle of a word. And then you have language-dependent mappings, and the sort of most obvious one there is the Turkish situation, where I has got a dot on it, and they look at the I as intrinsic to the I-ness. So the capital I should still have a dot if it has a dot in lowercase, and if it doesn't have a dot in uppercase, it should not have a dot in lowercase, which is obviously interesting. So you need to implement that, and then other things. And I talked about this before, and I showed some examples. Just to point out, so that code inherited ideas from David's text case package, so not case-changing maths, leaving various arguments of various commands alone, and having a way of opting out of case-changing, which at the LaTeX 2E interface is called no case-change. Mechanism at the Explore 3 end is more flexible, but it uses the same ideas. So what have we done? So that was okay. And so we integrated that into the kernel a while ago, and it caused problems for overleaf, we heard that, and that was because it turned out some people had made some interesting assumptions about the nature of case changing, but fixed those. Anyway, so what's been the sort of new exploration? So the first thing was the mechanism I'd come up with. As I say, it can do locale-based case changing. But when we first integrated it into the LaTeX kernel, we didn't have an agreed plan exactly about how you would deal with picking up information from Babel and polyglossia about the current language. And so we introduced an optional argument to make up a case, etc. That could be done to a local override, but we needed an agreed mechanism so that users didn't, in the main, have to specify the language. So we've had some backward and forward discussions with Javier from Babel and Jürgen, who looks after polyglossia, and we've come up between all of us with a mechanism that works, which is we now have this kernel command BCP data, at which in the kernel, if you don't load Babel or polyglossia, it's US English, we've decided, because that's the reality. So if you don't do anything else, that will return some information, and it will say your document, as far as LaTeX is concerned, is in US English, because can't tell anything else. If you load Babel or polyglossia, they replace that with some code which looks up the data structures that they're using to track these things, and that means that you can automatically, LaTeX can then automatically know what language case changing should be using. And so if you're using one of the small number of languages which does need tailoring, so Greek, Turkish, Lithuanian, Dutch, German only, but the Germans opt in, so that's different. So you always need it for Lithuanian because it's a fundamental feature of the language. There's one or two others. Anyway, there's a list, some of which aren't in the Unicode CLDR because, I don't know, no one seems to be able to know how to add to that. But yeah, we've picked up various of those. But so that happens now automatically, which is, in a sense, it's what used to happen, but done in a different way. So rather than Babel and polyglossia having to sort of patch, make up a case, etc., and change their definitions, now they don't do that. Stuff just happens from the kernel. But hopefully that data's now, there's now an agreed interface, and other things which need to know that have got a single way of querying information from both polyglossia and Babel, which we think is a much better than trying to sort of query them separately, and that was just not a viable plan. Okay, so as I say, so I'd written the 8-bit code, and because I'd started with the idea that I wouldn't need to do the whole of Unicode in 8-bit engines, I didn't start off wanting to do that, and then it didn't look right. So I've gone back and looked at, so interesting question, how do you load all of the case information or all of the Unicode information into an 8-bit engine? Where do you put it? And also, parallel question, if you're going to do it in an 8-bit engine, how are you going to handle it in the Unicode engines? Because the initial solution was to use the UC code and LC code tables, which are built into those engines. But if you're going to load all the data for one engine, you don't really want different data structures with different interfaces for different systems. So it turns out that this is not a problem that just affects us. Anyone wanting to load Unicode properties has to worry about how they're going to deal with the whole of the Unicode range and track various things. And the recommended route, actually it's in the Unicode documents when you look back, having had it pointed out, is this idea of a two-stage table. So I wrote something for Tugboat about this. Essentially the way it works is a way of compressing the information. And the idea is that because there's a lot of repetition in that full range of Unicode information, you know, all the Chinese characters don't change when you case change them. What you do is you use two tables, or two-stage tables, so that's, you have the first stage is making the Unicode range into blocks, and the second one is, well, just saying and so you say, you know, the first block points to the second stage table, second block, etc. And so what you do is you end up with one list of just pointing to, the block list points to tables, and those tables then can be the same. So all the Chinese ones use the same second stage table. And it turns out that for case-changing data, you can get the whole of the Unicode range into about 50,000 integers. And that can be stored in TeX in font dimens, which is something that's in Expo 3. It's what's used to implement integer arrays, and so you can get all of the case-changing data for all of Unicode into pdfTeX. And in a reasonable amount of memory. And the point about the two-stage tables is they're designed to be relatively slow to build, but relatively fast to get the data out of. It's essentially just some very basic maths, and it points straight to the right value. Once you've done that, you can change. So you do that, and then you have to worry about the fact you're no longer trying to grab individual TeX tokens. You're grabbing code points. Obviously, again, that's quite easy to do. In pdfTeX, you just have to examine, you grab your first token. If it's a character, you look at its the value, the character code, and you then can work out how many bytes you actually need to grab. And if we know that all of our input is UTF-8, then we can just grab code points. So I just had to retool the internals. So instead of worrying about characters, they worry about code points, which of course is slightly slower for 8-bit engines than it is for Unicode engines, which always grab code points. But once you've done that, you avoid having to have two different code paths. And then you can, in principle, well, you can case change anything in Unicode, even if you can't typeset it, because there's no font setup, it'll still work. So if someone has a file name, for example, and they ask us to case change it, to lowercase it, then we can do that in pdfTeX, even if we can't typeset it. Once you do that, you need to have a mechanism for tailoring things, because so we're no longer using the UC code and LC code data, so provided interfaces for that, so we need some functions, so declare uppercase mapping, etc. So this is a way of tailoring these things. And again, because we're not talking about a one-to-one situation. So this also allows you to tailor one-to-many. So if you case change, well actually, Unicode never generates more than 3 code points if you case change code points. So the output argument to this knows that we only ever need a maximum of 3 code points. But this declare whatever case mapping is also set up to deal with the possibility that you might want to produce some kind of command on case changing, if particularly again in an 8-bit situation, life can get complicated. Greek, yes, Greek is the bane of my life at the moment. Anyone here? Well, I'm sure we've got people who know about Greek. So at least modern Greek, when you change uppercase it, you get rid of most of the accents and most of the diacritics, but that's complicated, and it turns out it's extremely complicated, and getting it right has been a monumental amount of effort. So part of the effort here is that there's a long tradition of handling Greek in particular ways in 8-bit engines, and some of the assumptions there don't really translate once you start saying, oh, we're just going to treat everything as Unicode. So yes, so you drop accents, except some accents, if you drop them, you then have to add a diaresis to the next letter if it's a certain letter, and if it's a breathing mark and it's on the first letter, then you keep it unless the next letter takes the diaresis. And there's a couple of things that are used for teaching purposes, but aren't actually used in proper Greek, and then you have the question about whether you keep them or not, and then, of course, so the other thing is, it's more tricky in 8-bit engines, because one of the best way to do this is to decompose your characters, Unicode characters, into the base character and the accents, and then you can examine the accents. And that's fine if you're using a Unicode engine, because if you don't get rid of the accent, they will just recombine at the engine level. But if you do that in pdfTeX, you've put Unicode has the accent combining character after the base character, and then all hell breaks loose in an 8-bit engine. So you have to watch for that as well, because you have to manually recombine. So this has been fun. But hopefully it's now all sorted, just about. So yes, so some of those details aren't in the CLDR, so that is problematic. and they're not in the ICU reference implementation either, which is also great. And yeah, so LRC, so Günther Milder, who is in charge of the Greek support for Babel, has been asking me lots and lots of questions in this area, but he's been sorting the 8-bit, where I've made enough suggestions that hopefully he's dealing with that for sort of legacy stuff. So yeah, so that has been a lot of fun. So the other thing I've added recently is the idea of being able to look at the general category. So Unicode classifies characters, things like, well, first of all, you can have it's a letter, it's a combining mark, it's punctuation, and then within that you can have it's an uppercase letter, or it's a whatever kind of following punctuation, and this, that, the other. And that can all be turned into numbers, and because we now have two-stage tables, you can store all of that, and you can look it up very quickly. Why have I added that? One of the things on the next slide will tell us where I'm wanting to go, at least partly with that. Okay, so yes, so ongoing questions about, so we implemented title casing, but exactly what that means is being backward and forward, so still a very live discussion with people on the GitHub issue about whether it should be called title casing. So again, Günther Milder pointed out that the implementation I first came up with, title cases the first letter. So title casing for Unicode is the fact that when you capitalize the first code point of a word, it might not be just the first code point. So Dutch is the classic example. I, J in Dutch should be, if it's the start of a word, you uppercase the I and the J. So you can't just say it's the first letter. And then Greek doesn't drop accents when you make just the first letter uppercase, and there's a few more complexities. But so I implemented it just for the first character of an input, whether it should be every word, whether it should be called title casing, whether it should be called something else. Live discussion, and then you can get to sentence casing and whether we should even go anywhere near that, because that's very much a language-dependent thing. So ongoing discussions, which I don't have a final answer to yet. I had some emails from Chris Rowley this morning about it, so but feel free to contribute. Better detection of non-letters. Yes, so currently the idea when you're picking out what's the first letter, that's done in a relatively simple-minded way using cat codes. That's why I've added the Unicode general category. It's on my mind, not a big priority, but to rather than look at the tech data, you look at what kind of code point is it? Is it a letter? That's what any other program would do. It would look at the Unicode category. So I'm sort of planning to go back and revise that area. Yeah, and also character token generation. So currently, so if you case change something and it generates more code points than you started off with, what category code do you give the second and subsequent code points? Do you check? Are they the same as the first one? Are they arbitrary? Whatever. And I think they should probably be generated by looking at the general category and saying, if this had been typed in, what cat code would it have got? Which we can tell from the general category, because I also write the code that sets up the cat codes by reading the Unicode data table. So, yeah, so there's some extensions. They're refinements. They're not major refinements, but they're just trying to tackle those little edge cases. And they were in my mind. Some of these were in my mind when I wrote it, but I was like, well, I can't tackle everything at once. So for the moment, we'll do this, and we'll see whether we can go back. Okay, yes, so the other thing is grapheme mapping. So I like this example. People will notice it's in the test cases. So spinal tap. So you look at that and say, if I ask people how many letters there are, I think most people in this audience would tell me there are 9 letters in spinal tap and 1 space. Does a computer think there's 9 letters there? Well, it depends on how you ask the question, is the bottom line. So what we want to think about graphene. So why do I say why this? So you see spinal tap, it has 2 letters which are not used in standard English. We have a dotless I, which does have a Unicode code point because it's used in Turkish and this, that, the other, so you can get at that one. And it has an N with an umlaut. Now, oddly enough, an N with an umlaut isn't a pre-composed Unicode character. Though the only way to type that in is to type in an N and then to type in a Unicode input and then type in a combining diaresis. So obviously, I did this in pdfTeX, so I just used the classical LICR input, which works fine. But the point is, if we asked how many code points, we'd get 11 code points, we'd get 10 non-space code points and 1 space code point. So the Unicode Consortium have addressed this, and they define something called a grapheme, which is a very sort of loose thing for, it's what a human being would think is a letter, basically. A human perceived character. And they, obviously, because people need to be able to do this for lots of reasons, there is a lot of data, there's an algorithm for working out how many graphemes there are in your inputs. So I've implemented this as a mapping. The actual amount of data here isn't too bad. The only thing I haven't covered is the business about making flags, which seems very, very odd. You can make, they need 2 code points, and I haven't implemented that. And I've documented that I haven't implemented that because it's very weird. But everything else is implemented. You don't need too much data, so this doesn't need these sort of 2. Actually, the data files here are structured in such a way that they're not so convenient for making a 2-stage table, and there's not that many code points, so it's not too bad. Most things that look like letters are letters, it turns out. A few things that look like, if you have a combining mark and a letter, that counts, that just combines together to make one grapheme, etc. So I've implemented a mapping so you can go through all the things, but I was talking to, there was a question come up recently, and it's been mentioned a few times, we probably want something that can pick out individual graphemes. I need a name and I need to actually implement it, and probably also the first thing. I suspect also, having loaded the general category data, probably also the first letter or the first character of a code point of a particular type. So, you might say, what's the first piece of punctuation in this input? And I suspect that's actually relatively easy to implement, having done all the hard work on all of the background. So it's a question of having the motivation to write some more interfaces. But I can just see it's going to happen because people ask all kinds of nuts things that they want to do with their input, which you never predict, but you need to do because it's certainly all doable. And the reason, I mean, one of the things, the reasons for exploring Unicode-land is it's definitely, although it may not be perfect, it's definitely the place to go and have your code live. So, and then maybe visit Islands of Tech, obviously. So that's it. I'd like to just finish off. So although this is an Expo3 talk, there's not really too much code in there. Thank Javier and Jürgen for useful discussions about BCP data. Peter Kanowicki, he's the guy who, he has the clearest explanation of how to implement a 2-stage table that I could find. So he's got an example in Python, which I basically ripped off, re-implemented in Tech to do the 2-stage table. Obviously, re-implementing it in Tech and making it fast is interesting compared to data structures in Python, but it's doable. And Gunter Milder, who has not only asked me about 1 million questions about Greek, but also has asked other questions about the case-changing situation and has found lots of bugs and has been a very useful contributor. And thank you all for your attention.
Thanks, Joseph. Okay, and we have already some questions.
Thank you very much. You were mostly talking about glyphs or characters, but Unicode also has some kind of algorithms for text handling, for example, like bidirectional typesetting. Do you think, or is it part of the plan to implement those algorithms as well?
No, so I mean, this is all macro layer stuff, and anything like that is all left. That's one for the engine, something like that. I mean, what I haven't said there, so I've said about breaking things into words, and at the moment, words equals breaking at spaces. If you read like the Unicode word breaking algorithm, it's horrible, and I really don't fancy, well, I'll probably end up doing it in the end, but at the moment I don't really have the motivation to implement, say, that at the macro level. There's quite a lot of data, there's a lot of different cases, and it's not easy. I mean, even the graphene one is, I mean, said it's relatively straightforward, which it is, but it's non-trivial. But conceptually, that one's quite easy. Some of the other algorithms are a lot conceptually more difficult, and I don't think that's a macro level thing. It just, the performance would be dire.
Yes, I think so. Yeah, thank you.
Okay, more questions? Well, I have one. You only discussed Latin-based scripts and alphabets.
Yeah.
What is it about other things?
What case changing or?
Well, in general, case changing, yes, but also like graphemes. I think it's tricky in some of the CJK and similar.
So as I say, I've implemented, so most of those other, so there's only a few scripts that have case at all, and so Latin, Greek, Cyrillic cover, there's a few others, but essentially that's more or less it. To a good first approximation, so you don't have to worry about case in most other languages, so that's means that they just pass through. Something like the graphing thing, so I say I've loaded all of the data, and the only thing that's not implemented is the flags. Everything else, including because of the way I've loaded the data, Hangul will be a bit slow, depending on where the code point sits in the list, because I've just used a simple comma list to store the data, so it's not going to be fast. So the only thing that would come is if we needed to address that, then I'd have to relook at how the data are stored, but all of the data is there, all of the algorithms. So I've taken, there's a test file in the Unicode repository to test the test file that you're meant to use, and I run that directly in our test suite. I skip the lines, there's a few that I know I haven't, there's a few about controls, things about line breaks and things that don't make sense in tech. There's the one about the flags, and I think they're the only ones I deliberately skip, but the rest, it passes all the tests, so it implements exactly the same for Hangul or CJK, or any CJK as anything else would.
Okay, cool, thank you. More questions? Doesn't seem to be the case, so thanks, Joseph, again.